5 grams. That's the number you've heard 1,000 times. 5 grams of creatine every day mixed in water for bigger muscles and better performance. And the science backs it. Creatine monohydrate is the single most researched sports supplement on the planet. But here's what almost no one talks about. Your brain is an energy hog. It's roughly 2% of your body mass, but it consumes 20% of your total energy. And it runs on the exact same ATP phosphocreatine system as your muscles. So the question isn't whether creatine affects your brain. It's whether the dose you're taking is actually enough to get there. The answer, based on new research from 2024 and 2025, probably not. And in this video, we're going to break down exactly why, what dose the science actually supports for cognitive benefit, why your body weight matters more than a generic scoop, and why roughly 1 in 4 of you watching this won't respond to creatine at all. To understand why dosing matters, you first need to understand the problem. Your brain needs a constant, massive supply of ATP, adenosine triphosphate, the molecular currency of energy. Every time you form a thought, recall a memory, or process what you're seeing right now, neurons are burning through ATP. Creatine's job is to act as an energy shuttle. Specifically, phosphocreatine, the stored form, rapidly donates its phosphate group to regenerate ATP when demand spikes. In your muscles, this is what powers a heavy deadlift or a sprint. In your brain, this is what powers working memory, processing speed, and sustained attention. Now here's the critical bottleneck. About 95% of your body's creatine is stored in skeletal muscle. Less than 5% makes it to the brain, and the reason is the blood-brain barrier. Creatine enters the brain through a specific transporter called SLC6A8. But this transporter exists only on the endothelial cells of the blood-brain barrier, not on the astrocyte cells that form the outer layer. That means the gateway is narrow. The transporter operates near saturation under normal conditions, so getting additional creatine into the brain requires either higher circulating blood levels or longer exposure times. This is fundamentally different from muscle loading, where saturation happens in 5 to 7 days. Studies using MRS scanning have measured brain creatine levels before and after supplementation. The typical increase? 3 to 10%. Compare that to muscle, where stores can jump 20% or more in under a week. The brain is resistant to loading, and that resistance is why the standard 5-gram muscle dose may be insufficient for cognitive benefit. Let's look at what the actual studies say. And I want to be transparent. This is a field where the evidence is genuinely mixed, and anyone telling you creatine is a guaranteed brain booster is overselling the data. The largest meta-analysis comes from Zhu and colleagues in 2024, published in Frontiers in Nutrition. 16 randomized controlled trials, 492 participants, looking at creatine across multiple cognitive domains. The findings were nuanced. Memory improved with a small to moderate effect size of 0.31. Attention time improved with the same magnitude. Processing speed showed the largest effect, an SMD of negative 0.51, meaning faster response times. But overall cognitive function and executive function did not reach significance. The largest single study was Forster and colleagues in 2023, published in BMC Medicine. Pre-registered, crossover, double-blind, placebo-controlled. 5 grams per day for 6 weeks. They tested Raven's progressive matrices for fluid intelligence and backward digit span for working memory. The result? A trend toward improvement on working memory. P-value of 0.064, but not significant for fluid intelligence. Their Bayesian analysis supported a small beneficial effect existing, even though it didn't clear the traditional significance threshold. The authors concluded creatine might have a small effect. Then there's the EFO opinion from November 2024, the European Food Safety Authority. They reviewed 23 studies. Their conclusion was blunt. The evidence does not consistently support a cognitive benefit at any dose studied. They noted that effects observed at high-loading doses of 20 grams were not replicated at lower doses. In rested, well-fed, healthy young adults at standard 5-gram dosing, the evidence is weak, and that's the honest red. This brings us to the central problem. The standard 5 grams was established for muscle saturation. It works beautifully for that purpose. But the brain has different transport kinetics, and emerging research suggests the threshold for meaningful brain loading is higher. A 2025 paper from Texas and M's Exercise and Sport Nutrition Lab stated it directly. Because creatine does not cross the blood-brain barrier readily, they recommend 10 grams per day to promote cognitive benefit. That's double the muscle dose. The emerging thinking, championed by researchers like Darren Kando and Richard Kreider, is that once muscle stores are saturated at 5 grams, additional creatine may spill over to other tissues, including the brain, bones, and immune system. The most dramatic single finding comes from Gorgi Nejad and colleagues, published in Scientific Reports in 2024. They gave sleep-deprived adults a single high dose, 0.35 grams per kilogram of body weight, roughly 25 to 30 grams. They measured brain phosphocreatine in real time using MRS scanning. Brain PCR increased within hours. Cognitive performance improved. A single dose producing measurable brain changes, something previously thought to require weeks of loading. I'm not recommending anyone take 30 grams in one sitting. That was a controlled lab study with medical monitoring. The point is, it demonstrates that higher circulating creatine can cross the blood-brain barrier more effectively when the brain is under energetic stress. So here's the practical dosing framework. For muscle performance, the standard is about 0.03 grams per kilogram per day, roughly 5 grams for a 170-pound person. For potential cognitive benefit, the research points towards 0.1 to 0.15 grams per kilogram, roughly 8 to 12 grams for most adults. Let me walk through a specific example. Say you weigh 180 pounds. Divide by 2.2, that's about 82 kilograms. For the brain dose, 82 times 0.1 gives you about 8 grams. 0.15 gives you about 12. Your target range is 8 to 12 grams per day. The critical nuance: this is not universally established. The EFSA couldn't confirm benefits even at higher doses, but the mechanistic logic is sound. You need higher circulating levels to increase brain creatine stores, and the Texas A and M recommendation of 10 grams represents the current best guess from the lab doing the most work in this space. Before you go doubling your creatine dose, there's something you need to know that most fitness content completely ignores. My read? At 10 cents per gram with a strong safety profile and plausible mechanism, creatine for cognitive optimization is a high floor, uncertain ceiling bet. The downside is $1 a day and some extra water. The upside, if you're a responder, is measurably better working memory, faster processing speed, and a brain with more energy reserves.